Hello guys, this is Saranjom from TechWeek. Once again presenting you lecture number 4 in DIP series. So if you haven't gone through my previous lectures, so please so see those, because you will not be able to learn this lecture. So what will we see in this lecture? That is a relationship between pixels, neighborhood and adjacency of pixels. So in previous lectures we have introduced digital image processing. After that we have taught steps in digital image processing, and afterwards we have digitized an image. So we are going around image. Its smallest element is pixel, so we will move around pixels. So pixel has some other pixels on the beneath, on behind, and forward, backward, and diagonals. So these pixels are called its neighborhood. So as you see that if we take reference the middle one pixel, so these all are its neighbors. So if we take XY, so this is its back neighbor, or 4 neighbors which are horizontal or vertical. These are 4 neighbors and which are in diagonal, so this is its diagonal neighbor. So these are, and if we see 2D image, so 2D image has x and y coordinates. So if we go back, x coordinate x minus 1 y, x plus 1 y, x minus 1 y plus 1, x y plus 1, x plus 1 y plus 1, x minus 1 y minus 1, x plus 1 y minus 1. So these are its neighbors. These all are its neighbors of this pixel, this middle center pixel. So going forward, I have told you that it has 4 neighbor and diagonal neighbors. So what are 4 neighbors? As I have told you about the set of horizontal and vertical neighbors. So these are horizontal neighbors and these are vertical neighbors. And if we go towards the diagonal neighbors, the set of 4 diagonal neighbors in diagonals, this one, this one, this one, this one, of this pixel. These are neighbors of this pixel, diagonal neighbors. So if we go again forward, 8 neighbors. So our 8 neighbors. 8 neighbors are the sum or union of 4 neighbors and diagonal neighbors, as if we have we see in this term equation that n8 is equal to n4 neighbor and n diagonal neighbor. You see in this picture that these are diagonal neighbors and these are horizontal and vertical neighbors. So the union of the whole 4 neighbor and 8 diagonal neighbors become with 8 neighbors. So union of 4 neighbors and diagonal neighbors. So we see about neighborhood of a pixel. So now we'll go towards the connectivity, how we connect one pixel to other pixel. So these are 4 type of connectivity or adjacency: 4 adjacency, 8 adjacency, and M adjacency. So what we do in 4 adjacency, that how these pixels are connected in four adjacent or four adjacent to each other. If we look that if we take pixel 1, so this and these are adjacent, or this can be connected. And if we take this, so this does not have the similar pixel or one on forward or in the or beneath. So as same as this one, this does not have in same pixel for backward or beneath, and same as this pixel, this does not have it same or similar pixel on its forward or above. So these two pixels can be connected on the basis of 4 adjacency. So coming toward 8 adjacency, if you take these pixels as a reference, 1 2 3 4 5 6 7 8 9 10, so we will take this reference and we will connect them on the basis of 8 adjacency. 8 adjacency means that can be connected on diagonals or on 4 adjacency. So if we look this pixel 2, it can be connected in a 4 adjacency and can be connected on 8 adjacency or diagonal adjacency. And if we diagonal this 10 can also be connected with this 2. So in this picture only these 4 can be connected, and if we see this 7 pixel, so it can't be connected with the other neighbors, as we see that this 70 is not included and 201 is not included in this vector, reference vector. So if we look that a pixel can be connected diagonally or on vertically or horizontally, so there is a mix in between, or there is a problem. So to solve this problem, we come with a mixed adjacency. So what is in mixed adjacency? Coming towards this pixel, this can be connected in this and in this. This can be connected this and this and this. This can be connected this and this. This can be connected this and this. So there are more ways to connect this pixel. So this come with a problem that pixel can be connected in more ways. So to make it unique, we come with mixed adjacency. What is mixed adjacency? If a pixel can be connected in 4 adjacent or 8 adjacent, so we will give priority to the 4 adjacency. If we again take this example 1 1 0 1 0 001. So we see that this pixel is connected, can be connected diagonally, or this diagonal or this diagonal, or we want to connect this pixel with this pixel. So we'll go towards 4 adjacency, not 8 adjacency. So we will go toward this and then this. So this is 4 adjacency, or connected to this pixel. So in this way we will connect or we connect the pixel to another pixel. So coming towards the coding part of the lecture, that is the neighbor out of the pixels. So first of all we will generate an image which will be in the form of 5 cross 5 pixels. This term im is equal to magic 5 will generate a random image of 5 cross 5 pixels with random intensities, and afterward it will display this image. And afterward this x is equal to input, enter x coordinate, will take input from the user with the x coordinate, and afterward with the input with the from the user with the y coordinate, and an option that which neighbors the user would want from the code, or so in this we have given the options: 4 neighbors, diagonal neighbors, 8 neighbors. So afterward we'll call the function in which we will give it the image we have formed above, and the options chosen by the users for the 4 neighbor, diagonal neighbor, and 8 neighbor, and the coordinates, 2 coordinates between which it will between which or the center pixel. Mm, so coming toward this function, so what this function contains: this function contains 3 main part. X, first of all we will randomly generate or locate the x and y pixel location 1 1 and 1 2, and afterwards we will obtain the row and column from the image, or this function will give us the rows and column of the image size image, and afterwards we will mm, we will apply the conditions on the neighborhood, or the options which user wants. If the neighborhood is equal to 1, so it will apply x is equal to x1 is equal to x minus 1, x2 is equal to x plus 1, and y1 is equal to y minus 1, y2 is equal to y plus 1, and afterwards it will apply a limit on the option chosen by the user. If this limit exceeds the limit of the image, so it will give us the message accessing neighbors not part of an image. And else if this the option lie in between the image, so it will give us the those neighbors. So I have already taught you about these neighbors, that how these neighbors come. So in this way all other parts come into view. If if he wants the diagonal neighbor, so he would insert uh, two digit to access the diagonal neighbor. And if he inserts 3, so he will get the 8 neighbors of that pixel. So if we run this code, so what we will obtain if we goes to run. So as I said that magic 5 will generate 5x5 image for us, in which there are some intensity values. It says that enter x coordinate, so I will give it 4. Enter y coordinate, so I will give it 4 or 3. So in image you see that 4 cross 3, 4 is the row, 4th row and 3rd column. 19, it must give me 19. And enter an option that you want: 4 neighbors, diagonal neighbors, or 8 neighbors. Suppose I want diagonal neighbors from it, so I will enter 2. Oh yeah, so I said that it will give us the neighbors of 19. So 6, 20, 18 and 2. 6, 20, 18 and 2. In the image you see that in diagonal neighbors of 19 are, this is our 19, diagonal number of 19 are 6, 20, 18 and 2. So in this way our neighborhood comes, or thank you for the coding part of the lecture. Thank you and be connected.